We're here talking about a remarkable case of exceptional preservation in an ancient fossil of a fish dating to over 300 million years ago. Most time when you think about fossils, you think about the preservation of hard parts, things like bones, teeth, shells, but sometimes, on rare occasions, we find the preservation of the soft parts. And in this case, we have the remains of a brain and the associated nerves inside the skull of this ancient fossil fish. Looking inside these fossils using CT scanning with X-rays, we found all kinds of interesting structures. This fish belongs to a group called the rayfin fishes. They include the salmon on your dinner plate, the goldfish in your bowl, and the kinds of fishes you'd see here in the Huron River in Ann Arbor. But this is an early member of that group. This is a creature that branches outside of the part of the family tree that contains all living rayfin fishes. So it tells us a lot.
It was pretty challenging to figure out how we would describe this fossil. So my role was comparing the morphology of brains that we know from living species and using that information to then figure out how we could describe and interpret the anatomy that we are finding in this fossil brain. When we first found this fossil, the first thing was all right, this is interesting. So now we know that fossil brains can preserve. That changes what we understood up to that point about the evolution of the brain in rayfin fishes. Early in their evolution, they were considerably unimpressive. And then we used that information to extract and reconstruct a 3D model of that brain. All these labels that you see are different important structures of the brain. So for example, CCE would be the cerebellum of the fish, then the middle part, those are some of the cranial nerves. In this 3D rendering, you can see the brain case using the information that we find from the bony part, the brain case, and the soft tissue part, the brain itself. We can then understand much better the evolution of the group.
This kind of fossil is really important because it provides us with really unique information about what conditions were like early in the evolutionary history of this major group of backbone animals.